Hey everyone, let's take a look at a projectile motion problem. What I've got here is a golf ball being hit at 50 meters per second off the tee, and the angle is 36.9 degrees above the horizontal, above the positive x-axis. And you'll see I've designated the positive x-axis here and the positive y-axis there. I get to designate where the origin of the system will be. To make my life simple, I'm going to put the origin at the point where the ball leaves the ground. So the golf ball flies off at 50 meters per second. There's a hole over here, and the flag is set at 225 meters away from the tee, right? And the pin is 25 meters above the level of the tee, right? So I've got to go up the hill a little bit. So not quite a flat surface, but it won't give us too much trouble, as we'll see here in just a moment. 36.9 degrees is part of a 3-4-5 triangle. That's why I chose that. And to make our lives even simpler, let's go ahead and set the acceleration due to gravity at 10 meters per second, right? Speed will change by 10 meters per second each second, hence 10 meters per second, or 10 meters per second squared in the vertical direction, right? Only acts in the vertical direction, and it's pointing down. All right, so my kinematic equations that I'm going to work with here, there's the x position that's equal to x naught, the initial position, and that's equal to 0 in this problem. I got to set that equal to 0, so that was my choice. Plus v naught cosine theta, right? That's the component of the velocity in the horizontal. Cosine theta, because I'm measuring my angle with respect to the horizontal. If the angle is not measured with respect to the horizontal, this may not be cosine. It could be something different, so be really careful with that. Watch the angle and its reference point before you determine whether that's sine or cosine, because that can change. But in this problem, it's pretty standard. V naught cosine theta, that's the initial x component, and then times t, because we're talking about position. There is no acceleration in the x direction, and so the velocity in the x direction does not change. In the y direction, I have the initial y position. That's also 0, so that's going to be easy. V naught sine theta is the component of the velocity up. That's going to be the initial y component of the velocity, and we'll get to that in a minute, times time. And then minus 1/2 gt squared, 1/2 at squared, right? Kinematics, it's plus 1/2 at squared, but the acceleration is g, and it points down. So the acceleration is g, down indicates that I put a minus sign in there. And then we have our t squared, right? All right, so let's find then the velocity. I've got 50 meters per second in this direction. And so the x component will be 40 meters per second. That's 50 times the cosine of theta, but the cosine of theta is 4 over 5. 50 times 4 over 5 is 40 meters per second. And then 30 meters per second in the y direction. All right? All right, so y, that's going to be the final position in the y direction. Now, when the ball lands on the plateau, it's going to be at y equal to 25 meters. So I've got 25 meters equals y sub 0, the initial position in the y direction is 0, plus the y component of the velocity, but that's 30 meters per second, times t minus 5 meters per second squared, t squared. Minus 5 because 1/2 of g is 1/2 of 10, and 1/2 of 10 is 5. In the x direction, I've got x, which I don't know what that is yet, that's what I'm looking for, equals 0 plus 40 meters per second t. And so this equation, the only unknown I have is time. So I'm going to solve this equation for time, and then once I have that time, I can put it into that equation to determine how far I've gone. All right, so let's do that. I'm going to bring the 5t squared to the left-hand side. So I'm going to have 5 meters per second squared t squared minus 30 meters per second t plus 25 equals 0, right? And so if I, heaven forbid I do this, I'm going to ignore the units for a second, and I'm going to divide everything by 5, and I'm going to get t squared minus 6t plus 5 equals 0. And the solution to this quadratic is t minus 5 times t minus 1 equals 0. And so the times, there's two of them, right? Because it's a quadratic, there's two solutions. There's t equal to 5 seconds, and there's t equal to 1 second. That's when y will be equal to 25 meters. Well, if I think about the path of the ball is a parabolic shape. It's going to be at 25 meters at some point on the way up, and it's going to be at 25 meters at some point on the way down. That's why there's two solutions here. This is on the way up, so this will be somewhere over here. This is on the way down, that's when it's going to land. So at t is equal to 5 seconds, the ball lands. If I put that 5 seconds back into this equation up here, I get 40 meters per second times 5 seconds, and that's 200 meters. And so the ball lands 25 meters shy of the pin. Hopefully it'll roll that far and make it into the hole. That would be a heck of a hole in one, right? But it's going to land at x equal to 200 meters, y equal to 25 meters. And so there's a projectile motion problem. Start and ending altitudes are different, right? We'll put all sorts of interesting snags into this before it's all said and done. But there's one example for projectile motion problem. Real quick, if I wanted to know what's the velocity when it lands, the x velocity never changes, right? So v sub x equals v naught cosine theta, end of story. There is no change in the x velocity. So this would be 40 meters per second. But in the y direction, v sub y equals v naught sine theta minus gt. And so this is equal to 30 meters per second minus 10 meters per second squared times 5 seconds. And so minus 50. So the velocity on the way down will be 20 meters per second. So the velocity of the vector then would be 40 meters per second I hat minus 20 meters per second j hat. That would be the velocity at this point, right? That would be the velocity. Well, it's not at the pin, but where it lands, that would be the velocity where it lands. All right, if you have any questions on this problem, please feel free to leave them in the comments, and I will answer you as soon as I can. Thank you.